Okay, please find page 31 in your packet and try this warm-up now. We will pause the video here for you to try all 4 problems. Okay, so for A, I see that 1 is greater than or equal to 0. So that's 1 plus 2 gives me 3. I see that negative 2 for B is less than 0. You have to be careful with the order of operations on this one. We have to first do negative 2 squared, which is 4, bring down the coefficient. So negative 4 plus 1 is negative 3. 0 is equal to 0, so 0 plus 2 is 2. And then negative 4, again, be careful, it goes into the top function. We have to first do this, bring down the coefficient, and we get negative 15. So today we're going to be talking about direct and indirect or inverse proportion. So let's start with direct. If a plumber earns $35 per hour, we're going to let X be hours and Y be money. So if they work 1 hour, they earn $35. If they work 2 hours, that's $70. 3 hours, $105, and so on. So in this case, the ratio of earnings to time, ratio being division, is 35 in every case. So whenever a situation results in a pair of numbers in which the ratio is constant, there is a direct proportion. So in this example, y divided by x is 35. And then you can see our specific definition. Y is directly proportional to x if there is a constant k called the constant of proportionality. And there's 2 ways to think of this equation. We can have y over x is the constant, or if I isolate y here and I multiply x over, we get this form, y equals kx. We'll pause the video here for you to fill in all of the direct proportion information. Okay, so now for number 2, a bus is traveling at a distance of 20 kilometers. So we're going to let x be our rate or our speed, and we're going to let y be our time. So if we are going 20 kilometers per hour, how many hours will it take me is 1. If I'm going 40 kilometers per hour, how long will it take me to go 20? That's just a half an hour. And if I'm going 60, that is going to take me a third of an hour. So the product of speed and time here in every case is 20. And whenever a situation results in a pair of numbers whose product is constant, there's an inverse proportion. So y is inversely proportional to x. We can have 2 forms of that. If x times y is a constant, or if we isolate y here, see how we get k divided by x. So if I look at this whole picture, the whole page, I want to point out something. There's usually 2 types of problems we're going to get. When you're given a chart of values, it's best to use the equations when k is isolated. So if you're given a chart, you can divide y by x to see if you get the same number, or multiply x by y to see if you get the same number. If you are given a word problem, an equation, I typically use this one, and we'll see that at the bottom. So if we're given an equation where one of the variables is isolated, so let's look at the circumference example. Circumference is c equals 2 pi r. Well, c kind of lines up with this y, and 2 pi lines up with the k, and r is like the x. So technically this is a direct proportion. And the same thing can be said for the area of a circle. The a is in the spot of the y. The constant is pi, and then the other variable is r squared. So again, this is direct. Okay, classify each equation as direct or inverse or neither. I like to write myself a little chart being visual. So direct is y over x is a constant, and inverse is y times x is a constant. So if we look at A, regardless of whether it's x or y in the numerator, I see that the variable divided by the variable equals the same number of 33. That is the same setup here as a direct proportion. B, there's no inverse or direct proportion with this plus, so this one is neither. Now for C, I don't have the constant isolated, so what I'm going to do is say A divided by B is 10. So that's going to show me that's direct. And then lastly for D, because the constant is 7 and it's a product, that's inverse. So now for our tables, I have to look for a pattern. So if well, first off, these should be labeled X and Y. So you can add that to your packet. Sorry, that's missing. So if I multiply the X's and the Y's and I get the same number, it's going to be inverse. Or if I divide, it's going to be direct. So let's see. Looking at this chart, let's look at the values for A that are nice, like 1 and 2, 4.5. And I think if we multiply, I think I'm going to get the same values. See how those all equal 2? Even if I do 5 times 0.4, these all equal 2. So x times y is 2. That is inverse. So now for B, whenever they include 0, it kind of throws me off. So I'm going to save those for last. And let's look at multiplication, just because I think that's easier to visualize. 1 times -1 is -1. 2 times 1 is 2. This is 3 times 3, that's 9. They're not equal. It's not inverse proportion. Let's try division. -1 divided by 1 is -1. 1 divided by 2 is 1/2. Also, not the same, so this is neither. And now if we look at C, all these fractions. Ooh, I see some integers over here with the 3 and the 4. I know that 3 divided by 4 is 0.75. So if I do 0.75 divided by 1, is that the same as 1.5 divided by 2? Yes. Half of 1.5 is 0.75. 3 divided by 4, 0.75. So all of those, if I do y divided by x, we get 0.75. So that is direct. Okay, for number 5, the time required to do a job is inversely proportional with the number of people who work it. All right, so this is a word problem. I'm going to go back to the equations then where y was isolated. So for example, this one says inversely. Inversely means x times y is k. So I'm going to isolate the y, and I'm going to think of this as k divided by x is y. So the time required, so time is inversely proportional to people. It takes 4 hours and 12 people to erect some football bleachers. So we're going to use this information to solve for k. So 4 hours, 12 people, k is 48. Now we're going to plug in 3 people. And we get, I'll put down here, 16 hours. Okay, so this next page starts your homework. Page 33 to 34 all. All the answers will be on Edline. Make sure to check.